Stats, what is up? This is Mr. Carlson, C-squared mathematics. 4.3 is what we're going to be doing today. Geometric and Poisson. Very fancy. Poisson distributions. So these are the last two distributions that we're going to be doing. So notice how right here I'm going to be doing geometric and then Poisson, and then unit 8, when we get to stats, our actual unit for statistics, it's going to be going over normal distributions. So we're not going to do that right now. We just finished binomial. We're going to do geometric today and Poisson, but it's actually rather a short lesson. Okay, so bell work, homework quiz, and then the 4.3 lesson with summary at the end. So I'm going to go through two questions that you'll see on the homework quiz for 4.2 binomial distributions. Here's what I am given so far. I'm given that 24% of people in a city eligible to donate blood actually do. So what is that? What's that percent? Well, that percent should be very easy. This is going to be my probability of success, so 0.24. Okay, 24% of people, you actually select 4 eligible blood donors, so that means my N equals 4, and ask them to donate blood. Now we want to complete the parts A through D below. I did cut some parts out. All I'm going to do is just A, the mean, B, the variance, and then C, the standard deviation. How do I do that? Well, remember my formula here is actually N times P. My formula is actually just N times P for 4.2, the mean. So it's N times P, but we also say that this equals my mu. And then right here, it's actually N times P times Q. Okay, this actually equals my sigma squared. These aren't my answers. And then this is my sigma equals radical N times P times Q. Okay, N times P times Q. Okay, now these aren't my answers. Okay, these are just my formulas. Could I do everything by hand? Yes. Will I? No. Okay, I'll do it on Desmos, and I'll show you how to do that right now. So, all right. So, what am I given? So, I'm going to go to binomial. So, this is binomial. Let's kind of switch this just a tad bit. Perfect. That's perfect. Okay, so binomial. I don't want to use PDF right now because PDF, I need to use CDF because CDF, I need to go through all of the 0, 1, 2, 3, 4 for my trials. So I'm going to use this one right here. My trials, I'm going to change this to 4, and then I'm going to change this to change that to 0.24. Okay. Change my max to 4. Okay, because that's what I want. And then, of course, you start to see that these change. So if I change that to, 1, they change, but it's not 1, it's 4. So what is my mean? What is my variance? What is my standard deviation? It is right here. It's right here in front of our faces. Okay, so my mean, just look, I'm going to transfer it all the way over here. My mean is 0.96. My variance is 0.7296. Okay, my variance, my var, my variance. Standard deviation, this is 0.8542. That is my standard deviation. So very simple stuff, just plugging it, just a couple things, and then you get the answers, baby. I mean, awesome. So let's erase this. Let's move on to this next one. So 33% of college students say that you use credit cards because of a rewards program. I do have a rewards program on my credit card. It's freaking amazing. You randomly select 10 college students. So far what I have is N equals 10. Okay, I randomly select 10. And then my P is 0.33. So those are my variables. Find that the college students find the number of college students who say they use credit cards because of the rewards program. For A, exactly 2. So probability of 2. So this means PDF. Okay? So this means I want to use my PDF function. For B, okay, more than 2. So this is probability of x greater than 2, which is the same thing as saying probability of 2. Sorry, not 2. It's greater than 2, but not greater than or equal to 2. So that means it's going to be starting with 3 plus the probability of 4 plus all the way to the probability of 10. Okay, so this is a rather big one. I will be using CDF. Okay, and then C between 2 and 5 inclusive. So that means the probability of 2 and 5 inclusive. Now notice how I'm using equal to signs here. That's what it means for inequalities. Remember our set notation from week 1. So this means the probability of 2 plus, and then all the way to the probability of 5. And yes, I will be using CDF. So this is how I set it up, and then I want to know what it equals. So let's start with the probability of 2. Let's go over here. Awesome. So let's do the probability of 2. Let's select my PDF. So my n is not that, it's 10. I scroll over, I get rid of that, it's 33. And then I need to scroll over to 6, and I need to change that. So I want exactly 2, so I hit 2. Boom, that's my probability. So let's write that down. Let's write that down. So I'm going to, wow, that's actually, let's do 0.199. I'm going to round it to 3 decimal places. Awesome. Okay, so that's the first one out of the way. Let's go to the next one at least, at more than 2. So I'm going to change this to 10, 33, and then I want my min is 3. That's why I write this out so you can see, okay, 3 to 10. When I say more than 2, I want 3 to 10, so I'm going to go ahead and do 3. And then I want to do 10. That is my probability. Boom. Awesome. Okay, so this is 0.0.69, and then let's do 3. Perfect. Boom. Okay, so that is that one right there. Now let's go to the next one. So this is going to be 2 to 5. This is CDF as well. Okay, CDF as well. So that means if I'm going to be using CDF, I want to go back. I'm not going to change this because that doesn't change, right? My probability of success and my trials do not change. But what does change is my min and max. My min now changes to 2, and my max is not 10, but it's going to be changed to 5. So now it's 2 to 5 inclusive. That is my new probability. So 0.81, and then let's do 88. Let's do 4 decimal places. So make sure you are rounding to the 4 decimal places or whatever decimal place they want you to round to. If you don't round correctly, of course, you can ask for partial credit, but let's get it right the first time. Let's get it right the first time. Awesome. That is how you do that. I'm going to erase so you guys can get started on your homework quiz. 5 questions, 25 minutes. Open notes. So get started. Get started. Now, what we're going to be doing is the 4.3 geometric and Poisson distribution. I love this from Winnie the Pooh. It's great. So binomial, it's like it's all right, but Poisson, it's solid. Okay. So we're going to be using 2. The first page of your notes will just be. Actually, it's really just. We're going to be doing like half and half. So I have like half of it right here with geometric. The other half is Poisson and on the back, and then we just have a lot of practice problems that we'll kind of go over and everything like that. So I think that will be solid. Sweet. Okay. Let's get to it. And also on your notes, I actually want to show you on your notes. Remember, if you go to Google Classroom on your notes, you'll have this whole page of just awesome stuff. So what this is it actually goes through the binomials, it goes through the summary and the trials, the formula, and then also goes through geometric, the formula, and then the Poisson, the formula down there. Okay, so that's on your notes. It's also on the key. So make sure you are looking at your notes, your note packet, and so forth, because I'm telling you, it's very, very important. So this is another video to a crash course lesson. If you want to watch that, you don't need to watch it, of course, but for geometric, it's definitely interesting. Definitely interesting. If we're in class, we would watch it. But here's the definitions for geometric. Geometric distribution is a discrete, of course. All of them will be discrete this week. Discrete probability distribution of a random variable of x that satisfies the following conditions. So first of all, trial is repeated until success occurs. Second, the repeated trials are independent of each other, just like binomials. The probability of success, p, is constant for each trial. And then the random variable x represents the number of the trial in which the first success occurs. So this may make really no sense to you at all. That's completely okay. We're going to go through a couple examples after I give you the formula. So this is the probability of x equals the probability of success times the probability of q, all to the power of x minus 1. The reason why it's called geometric is because it's very, very similar to our geometric formula that we did in Algebra 2.1. And so it looks like this, where my q equals 1 minus p, of course, because that is my complement. Okay, so this is really my formula right here. That's the bulk, that's the meat. And I do have it in Desmos, the geometric distribution for you in Desmos. It's a little bit different though, so just bear with me, but we're going to go through it. So if you're a big basketball player, I hope you are, because I love LeBron James. He's good stuff. Basketball player, LeBron James makes a free throw shot about 75% of the time. That's a real life statistic. I actually pulled that out. So that kind of sucks for him, to be honest. But 75% of the time, find the probability that the first free throw shot he makes occurs on the third or fourth attempt. So the first free throw shot he makes would occur on the third or fourth attempt. Now, how do I actually set this up? Before I get to Desmos, let's kind of use our variables here. So what's my probability of success? Well, of course, that is 0.75. My probability of not success is, or a failure is 25. Okay? And then, of course, I have my x equals 3 here. Okay, 3 and 4 technically. Okay, I'm going to be using 3 and 4, so third or fourth attempt. So I'm only going to be using those. Okay? And so when I have all this stuff kind of put together, I'm actually going to do this one probably by hand. Okay, but we'll see. What this is going to look like is this, guys. So the probability, actually this is getting way too close. Let's do a different color. Let's do red here. So what does this look like? This is going to be the probability of 3. Actually, let's even go back. Give me 1 second. So this is going to be probability of 3 or 4. Now remember, or means plus, so that means it's going to be the probability of 3 plus the probability of 4. Okay, so this is my formula. Now, how do I do this? So the probability of 3 equals some number. What is that number? Well, let's plug it into our formula. Remember, my formula is P times Q, all to the power of x minus 1. This is the probability of x. Okay, so it's going to look something like this. All right, so my P right here is 0.75. Okay, and then times my Q, which is 0.25, all to the power of x, which in this case is 3 minus 1. When I simplify this, and I can simplify this on the calculator, I can do it right here, which in fact I probably will do. So let's actually do that really, really quick. So this is 0.75, okay? 0.75 times 0.25, and then all to the power of 3 minus 1. So I get this this answer. So I'm going to go ahead and over here, I'm going to write that down. So this is going to be 0.047. Let's round there. Okay, so this is my 3. Now, what's my probability of 4? So I do the exact same thing. Literally. I write down the exact same thing. What changes though? 4 minus 1. So now what changes is 4 minus 1. So I'm going to go over here. I'm going to change this. I'm going to do 4 minus 1. And so that's my new probability. So I go over here and I'm going to do 0.0117. Now, how do I actually find the total probability? Find the probability that the first free throw shot from LeBron James that he makes occurs on the third or fourth attempt. What is that? How do I find that? Well, of course, I take probability of 3 plus the probability of 4, which is this plus this, which gives me 0.059. So this is my final answer. Now, of course, I can do that on the calculator. I could have even done it like this. So watch, if I copy this, paste, changed it to, let's just say 3. Okay, so now what I could have done is I could have said this is m equals, okay, and let's just say this is like n equals, okay. Now watch, I could have just done this, m plus n. What is that? My answer. Okay, so that's awesome availability stuff that you can do on Desmos. You can do tons of things. Okay, that's what I love about it. Now, this is the hard way to do it completely by hand. Okay, and then use some of the calculator. Now, how do you completely use it on the calculator? Let's erase all this. Let's erase all this. Now, to completely use it on the calculator, I want to click on this. Now notice how it's a little bit different, just a tad bit. It's a little bit different, of course. I'm actually going to change this and then to that. Okay. So it's a little bit different. So now I can change my, give me 1 second. I want to change these. Okay. So now what I can do is I can change all this stuff. Now notice you do need to plug in this like plus probability of 3 plus probability of 4. But the formula stays the same. But I can change my probability of success, which is 0.75. So I'm going to change that to 0.75. And then 0.25 is already there. And watch, look, it's already given to me. Wow, that's my probability. But I rounded it, 0.0585, which is the same thing as 0.059. Okay, now look at this. If I only did 3, look what I have. 0.04, right? Now if I just did 4, awesome. I get that thing too. So it really, all I have to do is just this, and I don't need to type anything else. I just adjust these, and it already multiplies it by itself. So probability of 3, I need to add that to it, and then I get that answer. So Desmos is still a helpful tool. And so now let's erase this, and let's get to my next one. So find the probability that LeBron James makes his first free throw shot on his third attempt. Okay, on his third attempt. Before his third attempt. So before, what is that? Well, first of all, my n will stay the same. So that's still going to be, I don't have n here. I don't have n's at all. Okay, that's the difference between the binomial and the geometric. My n's are not there. So my p, though, is 0.75. And then my x has changed. My x is going to be now 0, 1, and then 2. Okay? Actually, no, I'm not going to include 0. Now, why won't I include 0? I'm going to explain that in a little bit. Because in binomials, you do include 0. Okay? In binomials, you do include 0. Okay? And then my q. My q is still 0.25. So what will this look like? This is going to be the probability of 1 plus the probability of 2. Okay, and I could use that whole fancy formula, or I can use Desmos right here. Now, why don't I include 0? Because again, go back to the conditions. The fourth condition says the random variable x represents the number of the trial in which the first success occurs. So that's, okay, 0 and 1, okay, the number of trial until the first success occurs. Now, the first one says a trial is repeated until a success occurs. So that means you can't have 0 because then it's not geometric, right? So you repeat it until the first trial occurs. So that means you can't repeat it 0 times. That doesn't make any sense. Now you could do it once and then the trial occurs and success. Or you could do it twice and then the trial occurs and then success. But you can't do it 0 times because it doesn't occur at 0 times. Or else it would just be null, right? It wouldn't make sense. So that's why you can't include 0 here. You only do 1 and 2. That's why, okay? Okay, so let's go to Desmos and adjust this stuff. So I need to adjust only these. I don't need to adjust this at all, okay? This doesn't change because it's still going to be 75. Now I need to adjust this stuff. So I need to change this to be 1, and then I go over and I'm adding with 2. And then boom, I get my answer. So this is 0.9375. So that's roughly 94%. 94%. We are confident that 94% that LeBron James will actually make his shot before the third attempt. So he has a 94% rate because you only make 2 shots really on a foul, right? So 94%, boom. I mean, you have 2 shots there, right? He's going to make the 2 shots. He has a 94% probability. Fantastic. Let's move on to what we call the Poisson distribution. So I'm going to go ahead and close this, and I'm going to open up the Poisson soon. So what is the definition of Poisson? The Poisson distribution is a discrete probability distribution. Of course, it's discrete because I told you it's going to be discrete this year or this week. Of a random variable x that satisfies the following conditions. So I'm going to go actually through these really fast. The experiment consists of counting the number of times x occurs in a given interval. So that can be an interval of time, volume, area. This probability of an event occurring is the same for each interval, and the number of occurrences in one interval is independent. That's very important, independent of the number of occurrences in the other. So what is this formula? It's actually a really funky formula. Okay, is the probability of x equals my mu to the x power times e to the negative mu power. Okay, that's my mu, that's my little u, all over x factorial. Now this is a very, very funky formula, and thank goodness we are not ever going to actually use the formula by hand. Okay, we're not going to use the formula by hand. I'm just going to show you how to type it in by hand or how to write it in by hand, but we're going to be using Desmos, this distribution, a lot. Okay, so basically E is your irrational number, x, okay, or irrational number approximately 2.71828, and mu is the mean. That's all it means, okay? So I'll give you a minute to write that down, write that formula down, and then we'll get started on the other examples, and then we'll practice back and forth between geometric and Poisson, summarize everything, and then we'll be done. Okay. Now remember, E is going to be 2.718. That's actually a constant, by the way. And so since we don't really know how to do that yet, you won't really learn how to do that truly until Algebra 2.2. So that's why, Desmos does it all for us. The number of accidents per month at a certain intersection is 3. Okay? The number of accidents in a certain intersection is 3. So that means my mean number, my mu, equals 3. Okay? What is the probability that in any given month 4 accidents will occur at this intersection? Now, 4 accidents, that's my x. Okay? So how I set this up is the probability of 4, because that's 4 accidents, equals 3 to the 4th power, because that's my mean, to the x power times e, that's a constant, to the negative mu power, or negative mean power, which in this case is 3, all over 4 factorial. This is what it actually looks like, and thank our lucky stars we're not going to do it that way. Now, we could plug this into decimals even right here, and I can do it really, really fast. Watch. So 3 to the 4th power, and then times e, and then 2, the negative 3rd power, and this is all divided by 4 factorial, and then that's my actual answer. Now, do you want to do that all the time by hand consistently? No. I mean, seriously, you probably don't. How do I do it? I go over here. Just like binomial, you'll have a PDF, and then you'll have what we call a cumulative, right? So I want to use the PDF because we're asking exactly 4 accidents. Exactly 4 accidents. What's the probability? So I go over here, I do 3 because that's my x, or sorry, that's my mean, and that's my x. So write this down in your notes so you don't forget. So this is always going to be your mean attached to the function, and then dot PDF, and then this is going to be your actual x value, okay? So your mean is attached to your function, and then dot your actual x value. So this is your mean right here, which is 3. I already have that. And then 4 right here, okay? I'm going to already have that. And look, are they not the exact same? Oh my goodness, they are, okay? So that means it equals 0.168. That is my probability. I actually used this in a long story short, I used this at a job one time, in a previous job, and my boss was so impressed. I used this function to find certain problems with the machinery, and it worked. So it was good. I liked it. Awesome. So now let's erase that. Let's find this. Given the same exact information, okay, find the probability that more than 4 accidents will occur in any given month. So that means the probability of x being greater than 4. So what will that be of x being greater than 4? That really means the probability of 5 plus the probability of 6 plus dot, dot, dot. Literally to the probability of infinity. That sucks. Can we actually do infinity? Well, watch. We technically can. Now my mean's going to be the same, right? Now I can graph this, and this is what it looks like, guys. By the way, I'm going to show you what that is in a little bit. Now I can graph it. Now watch. I don't want 4. I want more than 4, which means I start with 5. And now watch. When I go to infinity, I'm just going to hit backspace and then off to the side. Now watch. Look what happened here. Look what happened. It automatically calculates to infinity. Now this is a weird one because in binomial and geometric, we had a beginning and then we had an end, specifically, right? Beginning and an end. Here we have a beginning and then no end. Okay, it just goes on forever, right? And that's okay if it goes on forever. It can go on forever. And that's okay. That's why we have the Poisson distribution. So it automatically calculates to infinity. Now, what if I actually do 1 million? Okay, 1 million here. It will, or like 1 billion. Notice the number doesn't change. What if I take a couple zeros off? Does the number change? No. What if I even do 100? Does the number change? No. So the number doesn't change because it's just a big number. It goes on to whatever, but we don't need to put in 100. We can just leave it as that, and it'll automatically calculate to infinity. Now, what is my actual answer? Equals 0.185. Round to 3 decimal places. Okay, now if I wanted to graph this, let's just hit graph and then I hit over. This is what it looks like. Now notice how all my dots are just going on forever, right? And I can even zoom up. And those dots, if I zoomed up really, really close, like it looks like it's actually crossing. But if I zoom up even closer and closer and closer, like these dots will not actually cross. I know it's really hard to see right now. But if I go home and then zoom up, it's hard to see. Now this is, 4, that's 3, that's 2, that's 1. Okay, I don't want those. What I want is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so forth. Okay, I want all those. Now, how does it possibly add up everything together? That, my friends, is the interesting question. Okay, it does it a calculator. It's called an infinitely divergent, or sorry, infinitely convergent sum. Okay, that's the mathematical term for it. Infinitely convergent sum, and we learn that in calculus. We also learn it in some pre-calculus and stuff. So if you're interested, you can take it. But yeah, awesome. So that's what it is. Okay, Poisson distributions. So now let's actually, put it back. Let's actually erase this and let's start practicing. Okay, so during a promotional contest, a soft drink company place winning caps on one of every 6 bottles. Like I know Mountain Dew used to do that all the time. If you purchase 1 bottle a day, find the probability that your winning cap will be on the fourth day, first, second, or third days, and sometime after 3 days. Now, the first question is this geometric or is this Poisson? I'll give you a second to kind of think that through. Is it geometric or is this Poisson? Well, it is geometric. And the reason why it's geometric is because you are continuing the trial until you find success. You are continuing the trial until you find success. That is the difference. With Poisson, you have a mean. Okay, if you don't have a mean, it's not going to be anything other than, if you don't have a mean, it's not going to be Poisson. It could be other something else. But if you do have a mean, it's not going to be anything other than Poisson. Okay, so since you don't have a mean, it's not Poisson, so that means it's geometric because you're continually getting bottles, drinking them, and finding the cap and so forth, right? Okay. On the fourth day, let's find what this is. This is going to be the probability, because this is geometric. Probability of the fourth day. So let's go to geometric here. Let's change this. So let's actually find off to the side what's my probability of success and what's my probability of failure. My probability of success is really just 1 out of 6. Why is that? Because it's 1 out of every 6 bottles, right? So that means my probability of failure is the complement, 5 out of 6. And yes, we can type that in. So we can actually type in 1 out of 6. So we can actually go over here and erase this, and we can just do 1 divided by 6. Okay? And then we can erase this, and we can just do 5, 6. You can definitely do that. Okay? Now, I don't want any of this. All I want is the probability of 4. So I change that to be 4. And that is my answer. I go over here, 0.096. Boom, right there. Awesome. That's it. Now, what's the probability of the first plus the second? Or, because it's or means plus the third days. Let's find out. So I go over here. I change this to the first. And then I do plus the probability of second. And then plus the probability of third. And that is my probability, 4.21. So I'm going to go 0.421. Perfect. Sometime after 3 days. So that is kind of hard. How do I do that? Sometime after 3 days. So what does this mean? So what this means is sometime after 3 days. So that means it's literally at least 4. Okay? So at sometime after 3 days, what this is saying is 4 or more. Okay? So that's saying 4 or more. 4 or more, which is the same thing as saying at least 4. Okay, now how do I do at least 4? That means 4 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus. Can I do this over and over and over again here? I mean, I don't have something like Poisson where I can just go to infinity, right? Like, I don't have that. Like, look down here. With Poisson, I don't have that infinity. With Poisson, I have the infinity option. With geometric, I don't have that infinity option because Desmos isn't awesome in this one regard and doesn't actually make me a geometric one, right? So what do I do? Well, what I could do is just do the complement of it. So at least 4, I can do the complement of that. What does that mean? That means I can do everything besides 1, 2, and 3. So how do I do everything besides 1, 2, and 3? Very easy. All I have to do is just put it in parentheses and do 1 minus. That is it. So I just put it in parentheses, everything in parentheses, make sure everything's in parentheses, and just do 1 minus. So if I do 1 minus, that means I get everything besides that. I don't want 1, 2, and 3. I want 4 and above. So that means I have the probability of 1 plus the probability of 2 plus the probability of 3 plus all the way to the probability of infinity, which is the same thing as saying which is the same thing as saying 1 minus the probability of 3 plus the probability of 2 and then plus the probability of 3. Okay, that's the same thing. And this, of course, equals 0.5787 as my final probability. I get it right here. Okay? Sweet. All right, we're just going to town. That is how you practice geometric sequences. I'm going to erase this, and now let's go to Poisson. All right, let's go to Poisson. So Poisson, I know it's Poisson because they're going to give me a mean. Okay, but the mean's going to be a little hard to find, so pay attention. Pay very close attention. During a 36-year period, lightning killed 2,457 people in the United States. That's sad. And that's a real statistic, by the way. I just don't remember what 36-year period. Assume that this rate holds today and is constant throughout the year. Find the probability that tomorrow no one in the United States will be struck, one person will be struck, and then more than one person will be struck. So first things first, I need to find my mean. Okay, what is my mean? Well, think about it. 2,457 people in the United States died in a 36-year period. So 2,457 per 36-year period. What this gives me when I plug into the calculator is 68.25. Now, if I want to find my mean even more, because that's not my mean, because now I'm thinking this is per year, right? And I need to make sure it holds constant throughout the year. So what is the mean that you get in a 36-year period? In any given year, what's the mean that you get struck by lightning? That's what I'm trying to find right now. So I need to manipulate this. And I need to divide this even more so by 365. Because that's how many days are per year. So in any given day, what's the percentage of you getting struck by lightning? Okay, when I divide that, I get 0.19. This right here is my mean. So now that that's my mean, I'm going to go over here. My mean now is 0.119 or 19. And then my x is going to change. My x is going to change depending on what I'm asked. So now right here, my mean is 0.19, and then my x, no one in the United States. I forgot the no one here. So no one in the United States. Okay, so no one in the United States, if this is Poisson, and this is my mean, which we found out earlier, and then this is 0, because no one in the United States, 0, will be struck and killed by lightning. That means I'm going to plug it in accordingly. Okay, so I'm going to go to my mean. I'm going to type in 0.19. That's my mean. And then my PDF is 0. Okay, So that means right here, the probability of zero, the probability of getting to 0 people is going to be 0.827. And that's actually a fairly high probability. And that makes sense because, I mean, who gets struck by lightning, really? One person will get struck by lightning. What is this? Well, this is just the probability of 1, which means x equals 1 right here. Okay? And that's what I'm going to plug in. So that means everything stays the same, but I'm just going to do 1. So now my new probability is 0.157. Perfect. Now, more than one person. More than one person. More than one person is the same thing as saying at least 2. So if I say more than one person, it means at least 2, which means I need to do something a little bit tricky here. I actually need to do 1 minus. Okay, 1 minus my actual probability of x equaling 1. Because I can have one person obviously get struck by lightning, and that's what that is right there. But I want more than one person, so at least 2. So I'm going to go and do the complement of this. Okay, I'm going to do the complement of this. There's a couple ways I think you can do it. So right here, I'm going to go right here. Just this is 1. I already have this. Now all I have to do is just do 1 minus. Okay, and it adjusts it accordingly. Okay, notice how I just went right before it and just hit 1 minus and adjust it accordingly. So 0.842 and then 9. Now maybe some of you, and this probability is not going to change that much, but some of you may be thinking, well, can't you still have 0? So that's not really completely accurate because it's at least 2 more than one person. So you could still have 0 in there. That's granted. And so what if we did this? So 0.19, and then we did, this would be 1, and this would be 0. And then we just did 1 minus this. So 1 minus that. Okay, that would be the CDF. But it seems like you can't do that, and that's why we don't do it that way. Okay, so it's right here, but then what we'd have to do is just, or let's just try this. Let's just play around with it. Let's do 1 minus Poisson distribution of 0.19, and this is point CDF. And then from, let's do 0, 1. Let me think about that a little bit more. Okay. Let's do this example. Let's do this one. I think this one is probably the more correct one right here. Now that I'm looking at it, because think about it, more than one person will be struck by lightning tomorrow. That's a pretty low probability, and so if I'm getting 84%, that seems kind of odd. Like that kind of seems like it's not necessarily correct. So let's erase all that and let's just go right here. So that means what I did was 1 minus, okay, 1 minus the probability of 0 and then plus the probability of 1. So that's what I did, and what I basically just took the complement, and this gives me at least 2. So that means this is 0.0159. Okay, so let's do that. That's a lot better. Great. Well, that wraps it up. So I'm going to erase. Fantastic. So what did we learn today? We learned about geometric and Poisson distributions. We learned to find the probabilities, how to find probabilities using geometric, how to find probabilities using the Poisson distribution, and then we also looked at application questions and practice questions. So not a lot that we did today, but we still did a lot. So make sure you're prepared for the homework quiz. Do the homework. If you do the homework at 100%, you do get 100 on the homework quiz. Rather not. I wish I could give you 100 on the homework quiz. That would be great. Instead, I give you plus 2 extra credit points. So without further ado, guys, this is C Squared Mathematics. I'm Mr. Carlson. Be sure to like and subscribe.